A chiller's high inrush current can cause a temporary voltage drop, leading to voltage sag, which is a possible cause for the issues being experienced. Electrical noise from the chiller's operation can also affect other equipment. Loose connections in the electrical system can create arcing and voltage fluctuations when the chiller starts. An undersized transformer may not be adequately sized to handle the inrush current of the chiller, leading to voltage sag. Poor grounding can allow electrical noise and voltage fluctuations to propagate through the system. To investigate these issues, firstly, verify voltage sag using a power analyzer or oscilloscope to measure the voltage during chiller startup and compare it to the nominal voltage. Secondly, check for electrical noise by conducting an electrical noise survey to identify any sources of noise that may be affecting the system. Thirdly, inspect connections by tightening all electrical connections, including those between the transformer, main breaker, and main distribution panel. Fourthly, evaluate transformer size by calculating the chiller's inrush current and compare it to the transformer's rated capacity. Fifthly, check grounding by inspecting the grounding system for any loose connections or high resistance. Recommended actions include: firstly, installing a voltage regulator to help stabilize the voltage supply and mitigate voltage sag. Secondly, implement electrical noise suppression techniques using shielded cables, filters, or surge suppressors to reduce electrical noise. Thirdly, tighten any loose connections to ensure all electrical connections are secured to prevent arcing and voltage fluctuations. Fourthly, upgrade the transformer if it is undersized to one with sufficient capacity to handle the chiller's inrush current. Fifthly, improve grounding to ensure proper grounding to minimize electrical noise and voltage fluctuations. The hum and vibration of the main wires could be caused by mechanical resonance, which can occur when the frequency of the voltage fluctuations matches the natural frequency of the wires. It is important to isolate the chiller's load from other sensitive equipment to prevent interference. When a chiller starts, it demands a significant amount of current, referred to as inrush current. This sudden surge can cause a temporary dip in the overall voltage level of the electrical system, known as voltage sag. This voltage sag can affect sensitive equipment like lights, computers, and phones, leading to the issues of flickering lights, computer shutdowns, and phone disruptions. Electrical noise, which is unwanted electrical signals, can interfere with the proper operation of electronic devices. Chillers, with their large motors and electrical components, can generate electrical noise that can propagate through the electrical system. Loose connections can cause arcing, which is the flow of electricity through the air between two conductors. Arcing can generate voltage fluctuations and electrical noise, further exacerbating the problems. If the transformer is not large enough to handle the inrush current of the chiller, it can lead to significant voltage sag. A properly sized transformer is crucial for providing a stable voltage supply to the building. Inadequate grounding can allow electrical noise and voltage fluctuations to spread throughout the system. A good grounding system provides a low resistance path for fault currents, helping to minimize electrical noise and voltage fluctuations. To accurately assess the voltage sag, a power analyzer or oscilloscope is essential. These devices can capture the voltage waveform during chiller startup, allowing for a precise measurement of the voltage dip. The measured voltage can then be compared to the nominal voltage of the system, which is typically 120 volts, 208 volts, 277 volts, or 480 volts, depending on the building's electrical system. An electrical noise survey involves using specialized equipment to measure the levels of electrical noise in the system. This survey can help identify the sources of noise and determine the best way to mitigate it. A thorough inspection of all electrical connections, including those at the transformer, main breaker, and main distribution panel, is necessary. Tightening any loose connections can help prevent arcing and voltage fluctuations. To evaluate the transformer size, the chiller's inrush current must be calculated. This information can usually be found on the chiller's nameplate or in its technical documentation. The inrush current should then be compared to the transformer's rated capacity, which is also typically found on the transformer's nameplate. The grounding system should be inspected for any loose connections or high resistance. A ground resistance tester can be used to measure the resistance of the grounding system. A voltage regulator is a device that automatically maintains a constant voltage level, even when the input voltage fluctuates. Installing a voltage regulator can help stabilize the voltage supply and prevent voltage sag from affecting sensitive equipment. Shielded cables, filters, and surge suppressors are all effective tools for reducing electrical noise. Shielded cables have a conductive layer that blocks electromagnetic interference. Filters can remove unwanted frequencies from the electrical signal. Surge suppressors can protect equipment from voltage spikes and surges. If the transformer is found to be undersized, it should be replaced with a larger transformer that has sufficient capacity to handle the chiller's inrush current. The new transformer should be sized according to the recommendations of a qualified electrical engineer. Proper grounding is essential for minimizing electrical noise and voltage fluctuations. The grounding system should be designed and installed in accordance with the National Electrical Code, specifically Article 250. The hum and vibration of the main wires could be caused by mechanical resonance. This occurs when the frequency of the voltage fluctuations matches the natural frequency of the wires, causing them to vibrate. If mechanical resonance is suspected, steps can be taken to dampen the vibrations, such as securing the wires or using vibration damping materials. Isolating the chiller's load from other sensitive equipment can help prevent interference. This can be achieved by connecting the chiller to a separate electrical panel or using a dedicated circuit. In addition to the steps outlined above, there are several other factors to consider when troubleshooting chiller-related electrical problems. These include the age and condition of the electrical system, the type of equipment being used, and the overall electrical load of the building. A qualified electrician or electrical engineer should be consulted to perform a thorough assessment of the electrical system and recommend the best course of action. In some cases, it may be necessary to upgrade the entire electrical system to accommodate the chiller's load. This may involve replacing the transformer, main breaker, and main distribution panel. Upgrading the electrical system can be a significant expense, but it can also improve the overall reliability and safety of the building's electrical system. It is also important to consider the energy efficiency of the chiller. An inefficient chiller can draw more current than necessary, contributing to voltage sag and other electrical problems. Replacing an old, inefficient chiller with a new, energy-efficient model can help reduce the electrical load and improve the overall performance of the electrical system. Regular maintenance of the chiller and electrical system is also essential for preventing problems. This includes inspecting and tightening electrical connections, cleaning electrical equipment, and testing the grounding system. Regular maintenance can help identify and address potential problems before they become major issues. When working with electrical equipment, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing equipment before working on it. Electrical work should only be performed by qualified electricians or electrical engineers. The NEC National Electrical Code provides detailed guidelines for the safe installation and maintenance of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Electrical contractors and engineers must be familiar with the NEC to ensure that electrical systems are installed and maintained safely and in compliance with applicable regulations. Some specific NEC articles that may be relevant to troubleshooting chiller-related electrical problems include Article 250 Grounding and Bonding, Article 310 Conductors for General Wiring, Article 430 Motors, Motor Circuits and Controllers, Article 440 Air Conditioning and Refrigerating Equipment. When selecting conductors for electrical wiring, it is important to choose the correct size and type of conductor for the application. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation conditions. For example, NEC Table 310.15b16 provides ampacity ratings for conductors in raceways or cables. The ampacity of a conductor is the maximum current that it can carry continuously without exceeding its temperature rating. It is important to choose conductors with an ampacity that is sufficient to carry the load current, including the inrush current of the chiller. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when the current exceeds the predetermined level. The NEC specifies the requirements for overcurrent protection devices, including their size and location. It is important to choose overcurrent protection devices that are properly sized for the circuit that they are protecting. In addition to the NEC, there may be other applicable codes and regulations that must be followed when installing and maintaining electrical systems. These may include local building codes, state electrical codes, and federal regulations. It is important to be familiar with all applicable codes and regulations to ensure that electrical systems are installed and maintained in compliance with these requirements. In conclusion, troubleshooting chiller-related electrical problems requires a systematic approach that includes identifying potential causes, investigating the electrical system, and implementing appropriate solutions. By following the steps outlined in this guide, it is possible to resolve these problems and ensure the safe and reliable operation of the electrical system. Remember to always consult with a qualified electrician or electrical engineer for assistance with complex electrical problems.